Okay, there are a lot of applications in biology, in microscopy, images, right? So today any area of specialization that you do, you always look at certain images, right? So even for example, the mechanical engineering people will also look at, for example, for their welding, to see whether their welding is accurate or not. They take images and see, right? So I don't need to go into, to motivate you further to probably look at the applications of images. For example, a kind of satellite image which probably has certain distribution of vegetation, green pixels related to certain, trees or presence of trees, and some of these structures relate to the presence of buildings and other things. One can take a, aerial image and then aerial imagery, and then try to find out the distribution of how the different um, you know um, this particular area is um, distributed. For example, in an urban area, you will always find a lot of buildings, and roads and other things. For if you go to a remote area, for example, you will see some, the rivers and other vegetations and things like that will be there. So you will be able to, assess the intensity of crops that are being planted or things like that. You'll be able to understand. Again, GIS systems, geographic information systems. We talked about a lot of landslides and other things. So when you have to look at some of those classifications, okay. So we generally look at, these are, yes, aerial images. Talks about the presence of water bodies or rivers and things like that in a region, right? You get a flood sometime, some part of the, this probably looks at an image that has flood in certain regions where normal time, and you see in a flooded time, and how this you take sequence of images and then try to compare all of them to see whether. So law enforcement. So of course, people make use of today imaging systems for reading the number plates and then reading number of fingerprints are being used. So today, this face recognition is a very important application in many attendance systems, and gesture recognition, right? All these things can be, for example, facial detection. In a crowded area like this, you identify faces of each person, right? So, and then you try to recognize whenever there is a bounding box like this is put up onto the identified face, then you try to see whether who is the person, right? You can have, for example, a database of faces of people, and then try to match with the face with the of the person's face. Now there is something called template matching, right? We try to take the template and then take the face image, check whether the images are one and the same. Now, there are today face recognition systems are, for example, 99% accurate, right? 99% and above accurate. So you need to have 100% accuracy, but okay. So now image processing as a whole can be called as either low-level processing or a high-level processing. In a typical low-level processing, we do only certain noise removal applications, or we do restoration. For example, image is corrupted by something, you restore the original version. Again, image enhancement. We'll see some of those low-level to start with. We'll also look at certain high-level processing if possible. We'll also look at some matching algorithms as we go by. In another 1 hour's time, maybe we'll also look at certain compression algorithms. So, I don't know whether I'll be able to do all of them here, but I will definitely be able to cover some of the portions here. Now, in fact, if time permits, on some other occasion, we'll be able to do some more high-level processing of